Hi y'all, in today's video we're going to be talking about orbital notation. But before we get started with orbital notation, there's a couple principles and rules that we have to go over just so that we can understand a little bit more of how to do and why we do orbital notation the way we do. First principle, I talked a little bit more about this in the electron configuration and noble gas notation video. So if you don't understand it from my brief explanation here, I'd go over to that video and listen to that part. But basically, the off-bow principle says that the electrons must fill the lowest available energy sublevel before filling up the higher ones. We start here at 1s and it goes all the way down till we get to 7p. If you follow the periodic table, it goes in a line. It'll continue. So what this line is, it's saying that throughout the periodic table. That's basically the off-bow principle in a short couple sentences. The next principle you need to understand is the Pauli exclusion principle. This one says that two electrons in the same orbital must have opposite spins. In some cases, you may want to do your writing it down with an actual arrow pointing up and pointing down, but I like to do the half arrow. Either way, we are to put the electrons in the same orbital going opposite spins. The other thing we need to know before we get started is Hund's rule as electrons. So it says, as electrons fill a sublevel, all orbitals receive one electron with the spin before electrons begin to pair up. So like in 1s and 2s, these fill up completely and you start to put the opposite spins like in Pauli exclusion's principle. But with 2p, you're going to fill up this first one and then the second one, the third one, and then go back to this first one. This is the orbital notation for oxygen. Like I said, you're going to fill up these ones first, going the same way. So the only orbitals this applies to are the p orbitals, the d orbitals, and the f orbitals. The s orbitals, well, technically the rule applies to the s orbitals, but the s orbitals can only hold 2 electrons, and so those have to go opposite of each other. But for this one, they're all going to have 1 electron per line. Each of these lines can hold a max of 2 electrons, as you can tell from 1s, 2s, and 2p. They can only hold up to 2 electrons per line. The s orbitals can hold 2 electrons. The p orbitals can hold up to 6. The d orbitals can hold up to 10. And the f orbitals can hold up to 14. That's all you'll need to know for the rest of this video. Alright, let's look at an example. Our first one we're going to look at is lithium. Now, excuse me for a second as I adjust the camera so that you can see the entire thing. Now, we won't need to get all the way to the top here for the first couple because they are rather small and have a lower amount of electrons. So, lithium, it has 3 electrons in total. So we're going to need to get to 3. The first orbital we're going to fill up is always going to be 1s. So we've got 2 electrons down here, but we need to get to 3. So we're going to go to the next orbital up, which is 2s. Here is the orbital notation for lithium. It has the 3 electrons. They're going the opposite spins on the first orbital. Let's look at another one. Our B. B is boron. Boron on the periodic table has 5 electrons. So our 5 electrons we're going to have to put in these orbitals. We're going to start at 1s. I like to start my arrows going up, but you can start your arrows going down as long as your arrows are going the opposite ways. Like in Pauli's exclusion principle, they need to be going the opposite spins. So to get to 5, we're going to put 2 here, 2 in 2s, and then we go up and put 1 in 2p. Here is the orbital notation for boron. Let's look at another one. This one, we have oxygen. Oxygen on the periodic table has 8 electrons. These 8 electrons, we're going to fill up these orbitals. So, we always start off with 1s. Going to do 1 arrow up, 1 arrow down. There's 2, 3, and 4. We need to get to 8. 5, and because of Hund's rule, we're going to not put another one here. We're going to go to the next one. 6, 7, and we go back. 8. Here is the orbital notation for oxygen. Let's look at another one. We have neon. Neon on the periodic table is number 10. It has 10 electrons. It's also a noble gas. So we're going to go 1 arrow up, 1 arrow down. There's 2. Another one. There's 4, 5, 6, 7, 8, 9, 10. Now, one thing you may notice, or may not notice yet, but all of the noble gases, their p orbitals are full. Their valence electrons come from s and p orbitals, but we'll get to that later. For now, all we have to worry about are the orbital notation. And that's the noble orbital notation for the noble gas neon. Let's do another one. We have magnesium. Magnesium has a total of 12 electrons. Its 12 electrons we're going to put into our orbital notation. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the orbital notation for magnesium. Now we have phosphorus. Phosphorus on the periodic table is number 15. It has 15 electrons. So we're going to put 15 on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we do that because of Hund's rule. They need to be spinning in the same direction before they can go in an opposite in each orbital. All right, let's look at another one. Here is chlorine. Chlorine is found on the periodic table. It has 17 electrons. So we're going to get to 17 electrons. 1, 2, 3, 4, 5, 6, 7. Whoop, I messed up there. That's not how you do that. Even teachers make mistakes because we're all human. All right, let's try that again. We've got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's the orbital notation for chlorine. Let's look at this next one. This is titanium. So titanium on our periodic table is right here. Its number is 22. So we're going to get to 22 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We've got to 22. So this is the orbital notation for titanium. Let's look at another one. All right, Ag. Ag on the periodic table is silver. That has 47 electrons. So let's put 47 electrons on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. And silver's electron count is 47. Here's the orbital notation for silver. Let's do one more. All right. Lanthanum. This one has 57 electrons on the periodic table. Right here. 57. So let's put 57 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57. 57 electrons. And this has been the video on how to complete orbital notation.